of the workshop. And till now, we could do in the first day, that was the basic concepts. You learned regarding the measurement levels, the type of scale, regarding the reliability. Then yesterday, you did the exercise on the validity and reliability. And we discussed various type of reliability, and the most common type of reliability, which is the internal consistency that we performed on the JAMOVI. And then we did the validity. Basically, validity is also of three types. The content validity, which we did yesterday. The other two validity that is left. So today we will see the convergent and discriminant validity, because I said that we will do it in the factor analysis, because that's a construct validity. So in construct, when you see like how many domains are underlying, whether it is a single domain or multiple domain, then you do the convergent and discriminant validity. And then we will see the factor analysis today. So let's start the session. So coming to exploratory factor analysis, now there are two terms, and you will see in JAMOVI also in that drop-down menu, you will see there is a term which is the principal component analysis, and there is another term which is the exploratory factor analysis. So as the name suggests, exploratory. So as the name suggests, exploratory, what do we mean by that? That means, remember yesterday we discussed regarding the qualitative method design, when Dr. Nitin was asking like how we should have approach to that study. So in that we said that there are two types, exploratory sequential and explanatory sequential. So exploratory, as this term suggests, it is something related to like which is not known or maybe less known, and then you are trying to know more about that. You are going into exploring that particular domain or construct. That is the exploratory factor analysis. And the other term, that is the principal component analysis, that is again a type of exploratory factor, but the main difference between, what is the difference between the two, that we'll see today. So today's session, we'll in this session, in the first part of this, because there will be two breakout rooms today. One breakout room will be of exploratory factor analysis, and the second breakout room will be of the confirmatory factor analysis. And again, to reiterate the same thing which we have been discussing for the past 2 days, the type of measurement. There are two types of measurement scale. One is the reflective and the other is the causal formative. So this exploratory factor and the confirmatory factor analysis is done on the reflective type of scale. And if you can recall, a reflective scale is a scale where the items are a reflection of the underlying construct, and the direction of arrow is from the construct towards the item. That means construct is causing a change in the items. So this exploratory, before we start, there is a very unique thing which all of realize, but we often forget. So when we used to be a child, how our brain used to function and process the information. So many of you are mothers, fathers now also, or maybe there are kids at your home. So if you observe them, how a child brain process information. So like a child gets exposed to so many things, and it's we who tell them that this is this, this is this, this is sadness, this is anger, this is maybe when we teach them, this is the fruits. So we always ask them, name the 5 fruits, name the 5 vegetables, flowers, states, etc. So all these information, how they have come to know. So they are learning from us. They are learning through the society. So a child gets exposed to a lot of subjective and objective information. How that child's brain or the psychology process that information. So we tell them, and now the child registers all these informations in the brain, which is known as construct. So ultimately, these constructs are the mapping of information which is lying outside, and how that child, or maybe when he grew up, how he has processed that into the brain. So that is the processing of the information and having an image of those information. Like in this case, you can see a child analyzes all these informations and simultaneously learns to group these informations also as per social norm. Like child may say that these two, like apple and orange, that is a eatable, maybe egg and fish, that is a non-vegetarian item, and all these three, if you club together, that is under something which we eat. Then if you see the cycle and the car, that is a transport, and the two emojis, that is a very angry and happy, they are the maybe the emotional part. So as per social norm, the child processes these information, registers this information, and tries to club these information. Club means when he is thinking about the apple and orange, that construct of eatable or something fruits will come to his or her mind. So, and that is there till adulthood. So all of us gather so many information from our society, and that's the perception or mapping which we are having in our brain. And that's why we have so many prejudice, or you can say we are judgmental regarding things, although we don't know much about those things. So mental, if you are talking about objective things, like in this case fruits and vegetables, so that is quite easy because that is seen, something which is seen. So again, we talked on day one, something which is seen and something which is not seen. So in this case, it is seen, like all the transport event and all those, like we talked about tangible variable, like ultrasound machines, all those. So that is seen from the eyes, or you can perceive it, you can feel it. But what about these emotions? What about these construct? They are not tangible at all. They are an intangible one. Again, attitude. It's again an intangible word. You cannot measure it, you cannot see it. So subject grouping and mapping of all these subjective item is objective item is very easy, but subjectivity, all these emotional things and all those latent variable which are not observable, grouping them is a quite difficult task. So in this picture, what can you see? Yes, all of you, please type. What can you see in this picture? So Khushbu is writing colored balls. Anuja, net and balls. Haripriya, different color balls, ball and basket. Soni is writing net. Pratik is writing Shruti, balls that might need to cross net. Yes. Pavni is writing different color sports balls. Okay. Net and ball, volleyball. Okay. So yes, agree. All of you are right. There is a net and there are different color balls. Now, you will see that these balls are crossing this net and going to the other side. Again, that was a grouping of ball. And in this case, the second grouping is this. And this was the last one. So seeing these alignment or the grouping, what is your observation? What is your observation? Similar colored balls are together, grouped as per color shade, similar color shade, similar color together. Same shade together, similar ball together. Agree. So in this case, these individual balls, what are these balls? So if you take this analogy, these balls are like item. And what are items? Items we discussed. Items are the questions. So item are the questions. And what is this net? So net is basically the analytical term. Maybe this analytical methodology, which is the factor analysis, because ultimately this grouping or factorization, I should not call it factorization, because factorization is a mathematical concept. So these grouping and so these balls are the individual items, and you rightly said it, that it is grouping according to shade. And what is this net? And net is your factor analysis. So through this net, the color coding, similar color shades are grouped together. So this is known as the factor analysis. So it is easy to do this activity on color again, because color is visible, but it is tough to do so for items of scale, because psychological visibility, it's very difficult. You cannot visualize it. So this for scale validation, this net is, you can say it is the factor analysis, because when you run the factor analysis on a set of items, it groups the similar looking items or similarly constructed or similar item in the psychological domain together. So coming to the factor analysis, what is a factor? So now you understand what is a factor analysis. So basically factor analysis is a technique, statistical technique through which, so always remember the net whenever somebody says factor analysis, and then remember those colored balls. So balls are item, and what are the items? Items, you know now by this time what are the items and how we have reached to that item. And there are many criteria of forming those items. So items, basically it is formulated in a iterative process by 3 to 4 expert group. You do the pre-testing. After you form the items, you do the FGD, you do the key informant interview through your clinical observation. Like yesterday, Dr. Nitin was saying that they observed, they were having the idea regarding what questions to be asked in the knowledge assessing the insulin. So this factor analysis is basically a mathematical statistical technique which clubs the similar looking items or similarly constructed item together. And in this factor analysis, it actually measures the relationship of the scale item to the latent variable. Because if you can remember that picture or the figure where there was a latent variable which was affecting all the items. So it sees the relationship of the scale item with the latent variable. And then, you know that again, we discuss this, that the variation in the item is due to the variation in the latent item. Means latent variable or the construct is affecting these items. So if an item is having a variance of 60%, that means 60% of them is getting affected by the underlying construct, but rest 40% is either through some other latent variable or it is due to the error. So multiple latent variable can be a cause of variation in the set of items. So that's why we have to select item wordings in a way that it should correspond with the intended level of the variable specificity, and it is used to assess whether the selection process succeeded or not. Selection process means you have identified number of items from many items. Like generally what we do when you formulate an item, initially you will formulate approximately 100 to 150 items, and then you select maybe 50 out of that 150. So this factor analysis also suggests like the item which you have selected, whether they should be retained or few should be deleted. So it also assesses how was your selection process. And then there's something known as the classical measurement theory. So this classical measurement theory, it assumes that items, number of items which are there in a scale that is unidimensional. So it assumes that it is unidimensional, and then you perform a factor analysis and then tries to see how many factor comes out of it. So again, if you see this, I'm sorry, the direction of arrow in this picture is wrong. Ideally, it should have been the other way, because here the affect is what? Affect is the, we call affect as mood. So this affect is having, if the latent variable is the affect, and there are 25 items I have selected to measure this affect, then classical measurement theory says that there should be 25 factors of this affect. So if the latent variable is affect, so there can be various shades of the affect. Depression is one shade of affect. Then panic is another shade of affect. Then hostility is maybe again affect. Anxiety, again affect. So you can see, if I have to measure affect, then these are the various type of affect or the category of affect which I need to measure. Similarly, affect, there can be two poles, like there can be negative affect like tense, and there can be positive affect like calm. So this affect has got many shades. Similarly, sad and happy, again, affect, it has a combination of both positive and negative. So then what should I do? If I have to measure something and there are several affective states, so how will I come to know that this latent variable affect, which I am going to measure, how many domains it has got? It is breaking into how many sub-construct, you can say. So how to decide for that? So ultimately, factor analysis decides for that. So it decides how many latent variable underlie under a set of items. And again, this exploratory factor analysis or factor analysis, it condenses the information. Say, for example, in the big 5 personality item, which was the 51 item, if there are 51 questions, how you are going to present your result? So you can only do, like, you can present an overall score, but there will be only one analysis. But if there are multiple domains of that 51 questions, then your information would be condensed. And that was observed with the factor analysis, that those 51 questions were getting broken into 5 personality traits, which we discussed, like openness, conscientiousness, agreeableness, neuroticism. So those 5 domains we have seen. So ultimately what this factor analysis does, it condenses the information so that now you can present the result in that 5 personality domain. And it also identifies the item. So what do I mean by item? Item is a question, single question. So it identifies the items that is performing worse and better also. So better we will keep and worse we will discard or we will modify. So yesterday we did the reliability analysis, and in reliability what we have seen that there should be at least the value of the Cronbach alpha should be 0.8. So 0.8 Cronbach alpha suggests that there is good reliability. Good reliability means there is an internal consistency. That means all the items which you have kept, that is measuring the same construct. Now there are some limitations of this alpha. That's why the need of these factor analysis arose, because this alpha, if there is one more fact which we did yesterday. What was that? If you increase the number of items, your alpha will increase. Remember? So alpha of a 4 item and alpha of a 51 item. Definitely the alpha or the Cronbach alpha of 51 item will be more. And you have seen that it is non-linear. Initially it increases up till 10, then there is a stable increase, and up after 40, it's a kind of plateau. So the limitation of alpha is, first, alpha does not guarantee that all items reflect influence of a single latent variable. That what do we mean by this? That the alpha tells you, it assumes that the scale is unidimensional if nothing is known about the scale. So if you have formulated something, or maybe if it is known also, and if your population is taking it as a different, a domain or different construct, then you have to see. So high alpha, it never guarantee that all item reflect the single latent variable, because you will see that yesterday we discussed that at least there should be 0.3. So the rest item and rest of the correlation, there was a table and we discussed that the correlation between the item rest correlation should be at least 0.3. That means it is measuring the same construct. But it is seen that for a 25 item, even if only 0.14 inter-item correlation is there, then it will yield an alpha of 0.8. And again, I said that alpha is appropriate only for a unidimensional item set. It is, if you don't know about the dimension, then it may measure two opposite poles. Like we discussed, affect has got two poles, maybe sad and happy. But if you apply a scale to alpha, apply this alpha to a scale which has got opposite items, then this alpha may not detect it. So there it is misleading many times. So the beauty of this factor analysis is it is an empirical method. So what do we mean by empirical method? Empirical method is like you get the observation or analysis from the observed data. It is not based on any theory. You apply that on the population and you test that. So it comes from the data. And this factor analysis tells you, is there only single construct? That means is the scale is unidimensional or the scale is multidimensional. So the purpose, well, then what is the purpose of factor analysis? So basically factor analysis determine how many latent variables are there in a set of items. And again, we said that it condenses the information. Condenses the information means it breaks the 51 items into few factors so that analysis becomes easy. And again, it defines the meaning of the factors also, because after you have done the factor analysis, you have to name all those similar looking items. You have to club it together. So you have to define the substantive content or the meaning of that factor. And then you have to identify again the items which are better performing or worse performing. So in case of worse performing, either you will delete that item or you will reframe that item. So how this factor extraction is done? So basically this creates the factor. So this extracting, if you start from like initial, you think that I am starting from this point. So you consider that all the items are in one construct. That means that it is a unidimensional scale. Then in step 1, it detects like how much the variation of that item is explained by the factor. Let's say 40%. So 40% of the variation in that item is explained by that latent factor. Then again, what this model does, it sees that how much of the variation, so the left variation is 60%. So out of that 60%, how much of the variation is explained by another factor? Another factor means another latent variable, not the factor. Then it sees that how much of the variation is explained by third latent factor, and so on. So it keeps on getting loaded into the factor until the leftover variation is very small. We'll see this again in the analysis. I don't know whether have you understood this concept at this place or not, but we will repeat these concepts many times. So now in this case, since if you can see, this is a two-factor model. So this is again a reflective type of scale. In this case, these A, B, C, A to I, these are items. And what do we mean by items? Items are the questions. And the factor, this is the factor or the underlying construct. So this factor, the variation in these items are being reflected by the factor. Again, in the two-factor model, the left, so all the variations will not be explained by this factor 1. So this latent factor 2 will explain the other the left variation in these items. So in the course of scale development, our aim is to know like which item is getting loaded. So I will use the term loaded from now onwards. What do you mean by loaded? Loaded means the predominantly that item is getting affected by that factor. That I mean by loaded. So we want that most influential of item. That means the item which is getting affected by the most influential factor, we will consider that item in that factor. So the factor analysis basically is of two types. There is an exploratory factor analysis and there is a confirmatory factor analysis. So exploratory factor analysis is when nothing is known about the dimensionality of the construct and you do it. But you will see that these days, even if the dimensionality of the construct is known, then also we do the exploratory factor analysis just to see that the same dimension is there in our population or some other dimension. Like you will see that GHQ 12. So many studies have been done, and I think we have shared one article also with you people regarding GHQ 12 in the Chinese population, and they have come up like in their population, the domain is like 4 domain or 3 domain, and they have compared that with many other many other studies where they have tried to do these factor analysis on the GHQ 12. I don't know whether you have gone through that paper or not, but please go through that paper and article and you will come to know how this exploratory factor analysis helps in understanding the underlying latent construct. And then confirmatory, again, the second type is confirmatory, and we'll see that in the part 2 of today's session. So I'm not touching the confirmatory factor analysis now, only telling you about the exploratory factor analysis. So now there are some underlying assumptions of these exploratory factor analysis. The first assumption is there should be multiple variable, and the multiple variables are there, like all the items are multiple, and they are measured on continuous scale. So continuous means in this case, you can take scale variable. So yesterday, remember that we talked about the ordinal and the continuous. So ordinal variable is when there is a definite order, like all these Likert item. But in case of a factor analysis, since most of the Likert item are 5 and more than 5, so we treat them like a continuous scale. So this is one assumption. The second assumption is there should be linear relationship between the variables, and that you check with the scatter plot, and there should not be significant number of outliers. So if the sample size is large enough, and if there are few outliers, so you should ignore that, and you know how to do that. So those of you who have attended our basic JAMOVI and SPSS, you know how to check for these assumptions. If not, you can go to, there are many videos on this on the Merit India website, and you can check how to check for the outlier and scatter plot in JAMOVI and in SPSS. Again, the sample size should be large. So we say 5 to 10 per item. So EFA, for EFA, it should be at least 10. That means the number of items multiplied by 10. So in case of a big 5 personality data, if there are 51 items, at least we need 500 sample to do a exploratory factor analysis. In case of a stars, like if you have modified question, if it is of 35 questions, then 35 multiplied by 10. So it is 350. So I think Dr. Shamshad was telling we have received 264 data. 280. So it is a fair good number, and you can yourself check that factor analysis, assuming that we don't know about the dimensionality. And in the breakout room, you will do the analysis on that stars data, which you people have filled up to see it is breaking up into how many factors. And then again, the next is the sphericity and sample adequacy. And this we will see in JAMOVI, how to check for the sample adequacy. Yesterday also, I think one participant, Vishwanath or someone, asked for the adequacy, sample adequacy. So we'll see that today, how to measure the sample adequacy. Now there is something known as the multicollinearity. So what is a multicollinearity? Many of you know. Yes, can you please type in the chat box? What is a multicollinearity? As the name suggests, so relationship between the independent variable. Yes, agree. But what that is the maybe linear. How do you know that there is a multicollinearity? When the correlation is more than 0.7 between variable. Okay. Yes, good. So then when there is a high, I'm not going into the value of that correlation now, because this multicollinearity, there are various ways to check. In the linear regression, we check for these multicollinearity in logistic regression, in linear regression, and here in the factor analysis also. So multicollinearity is when there is a high correlation between the items here in this case. So items, yes. So items are the various questions. Like in this example, for those of you who is not having a fair idea regarding this multicollinearity, it says that all the items are having high correlation. So that's the multicollinearity. In this case, you can see, and that is always tested in a continuous nature of variable or a scale variable. In this case, you can see like there are various items. So can you figure out a common place through which these items are related to each other? Yes. Correlation kitchen. Yes, agree. So it is related to kitchen. You can keep all these items together. Maybe diet. Yes. So you can see there are various. Somebody is keeping it in diet. Someone is keeping it in kitchen. So these are the various construct. Okay. So like if you are the expert, the one expert will club these together as kitchen. The another expert may give another name, that is diet. And then again, you have to see like which one is more correct, whether it is diet or whether it is kitchen, right? So then you will see that the diet is a subcategory of kitchen, or kitchen is more broader than diet. So all these are the domain of discussion of expert. No, are you getting me? How these small things you have to clarify. Like, what do you mean by diet? Remember, we discussed about a theoretical definition, and then there is an operational definition. So this is just a simple example, but in case of scale and latent variable, you need to put a lot of brain regarding what name to give after this factor analysis. So in the same analog, when you use many items to measure a construct, then you can say that all these items must be correlated to a certain degree with each other. Because if they are correlated with each other, then only you can say that they all are measuring the same construct. If they are not correlated, that means they are not measuring the same construct. So the existence of such correlation between the all items of a scale is known as the multicollinearity. And this multicollinearity is checked with the assumption of the test, which is known as the Bartlett's test of sphericity. So this Bartlett's test of sphericity checks this assumption of multicollinearity, and the null hypothesis states that there is no multicollinearity among items. So then what should be the p-value to say that there is a multicollinearity? Please answer in the chat box. If the null hypothesis states that multicollinearity does not exist, so Pratik is right. Preeti is also right. So remember that we always reject null hypothesis. We always want our null hypothesis to be rejected, because in null hypothesis, we assume that both are equal or nothing is significant. Yes. So Nitin, Prashant, Vadehi, all of you are right. It should be less than 0.05. Now, sphericity and sample adequacy. What is sphericity and what is sample adequacy? So sphericity is Bartlett's test of sphericity. You have seen that it checks with the problem of multicollinearity, and it checks whether variables are related to each other or not. And the null hypothesis states that there is no correlation. That's why p-value of 0.05, it satisfies the assumption. And it says that there is an existence of significant correlation. So when this Bartlett's test of sphericity is less than 0.05, then only you can perform EFA on that data. Otherwise, that data set is not suitable for the exploratory factor analysis. So before you run the exploratory factor analysis, you should check this assumption. Coming to the second assumption, which is the sample adequacy. So how do you check for the sample adequacy? So one method we discussed, like you take the number of samples, 10 times number of items. Like if the number of items are 50, then you have to take at least 500 for exploratory factor analysis. So here there are objective way also to check that. An objective way to check for the sample adequacy is the KMO measure, which is the Kaiser-Meyer-Olkin measure. And it sees the proportion of variance among observed variable due to the common variance. So that common, what are the items which are there? How much is the variance is explained by the construct. And again, in this case, if KMO value should be at least 0.6. If it is 0.5, then that particular item is not suitable for the exploratory factor analysis. In that case, you need to increase the sample size. So now these are the KMO measure. So KMO more than 0.9. It is not 9, it is 0.9. It is very good. If KMO is between 0.8 to 0.9, this is meritorious. If it is 0.7 to 0.8, that is middling. At least it should be more than 0.6, which is the mediocre. Less than 0.6 is miserable. So it is, and less than 0.5 is not acceptable at all. So just remember, KMO value should be at least 0.6. Now there's another term in factor analysis, which is known as the eigenvalue. So I'm just introducing few terms. We'll again see these. I'm only telling you the theoretical part. We'll see it practically when we'll run the EFA in JAMOVI. So eigenvalue is the sum of the variance of that factor value. So I'm not going into the detail of what is this variance. I hope you know what is this variance. So variance is basically sum of square. And this in ANOVA and other concept, I hope you know. If not, then you may go and see the other sessions. What is a variance? So basically, this eigenvalue is the when you sum all these variances of that particular factor, this gives the eigenvalue. So if the factor has a low eigenvalue, that means it is not adding to the explanation of the variances of that particular item. So the eigenvalue is very important because there are three criteria how you should decide about the factor, how much factor you should take. So you can take all the factors where the eigenvalue is more than 1. There is something known as the Scree plot. When there is a plot between the eigenvalue and the factor, that is known as the Scree plot. And then there is something known as the parallel analysis. And in parallel analysis also, these eigenvalues are compared with the random data value. So I know that at this point, it might look a little confusing to all of you, but please just wait for 10 more minutes and then everything will get more clear. So right now, what I have told that you can take 3 ways to decide about what factors you should, how many factors you should keep. So this eigenvalue should be more than 1. And then examination of a Scree plot. So eigenvalue is for item. You will see that eigenvalue is for, means it is for all the number of items, and number of items are considered as a factor in this case, because I told you that in a single, it considers that there are 25 factors. And then it gets the loading, and then the factor which are most loaded with the item, you select those factors. So eigenvalue is for the factor. So you will select where the factor, this eigenvalue is greater than 1. So this you can see, this is a Scree plot, which is plotted between the eigenvalue on the y-axis, and this is the component number. So component number, what do you mean by that? Component number is the number of factor. So if the questionnaire has 25 questions, a scale, then it will break it into the 25 component. But you have to select only those component where the eigenvalue is more than 1. And how you will decide that? There is an inflection point. So point from where this seems to be parallel. So this is the inflection point, this angle. But it is not always easy to decide. So there are other ways, that is the parallel analysis, we'll see that. So if this is a scree plot, and scree plot is the plot between the eigenvalue of a factor and that factor itself. That means this one factor, if you see this factor 1 has got the eigenvalue of 6, more than 6, 7. Factor 2 has got an eigenvalue of maybe 2.75 because it is between 2 to 4. So maybe 3.75, not 2.75. Now there is another concept which is known as the communality and uniqueness. So I have introduced these terms maybe on day 1 also. What is communality and what is uniqueness? So remember, there was a diagram, I think I should have put that diagram here also, where there was an underlying construct and it was affecting all the item. And then error term was unique to all the items, but the construct was common to all. So this communality is basically the variance, which is the shared variance by the construct. And this uniqueness is due to the error, because in the reflective type of model, if you can recall, the reflective type of model, the error was attached to the individual item. Remember, I think one person has asked regarding how the error will be attached in case of a causal formative. So in case of a causal formative, the error will be attached to the construct. But in case of a reflective model, it will be attached to the individual item. So uniqueness is the proportion of variance that is unique to the item, which is not explained by the construct. And communality is 1 minus uniqueness, means the shared variance due to the underlying construct is the communality. Okay, so that's the theoretical definition of communality and uniqueness. If you perform this principal component analysis in or exploratory factor analysis in SPSS, it gives you communality, but JAMOVI gives you uniqueness. So it is same. The only thing is communality is 1 minus uniqueness. Same means you know the concept. So now what is communality? So communality is basically the amount of variance of an item which is explained by the latent variable or construct. And why we call it as communality? Because it is shared. Coming to the uniqueness, it is not shared. So uniqueness is unique for each item, and it is the amount of variance which is not explained by the latent variable or construct. So now in this case, this is just one example. So treat it as one item. This whole thing is one item. If I say that communality of this item is 0.72 or 72, then what meaning does it convey? So it conveys that the 72% of variance in this item, and if the total variance of this item is 1 unit, then you can say that 72% is due to the latent variable and 28% is due to the error, which is unique to this item, or some other latent variable. So have you understood this communality versus uniqueness? Yes?
Madam, is it due to error or can it be due to the unexplained?
Actually, there are two paths. It can be due to some other latent variable also. But because we don't know, that's why we call it as an error. Error means that is not explained by the construct which we are going to study or which we have taken as our research question, which we are going to measure. Is it okay?
Yes, ma'am.
Or do you,
Yes, ma'am.
you don't seem to be satisfied with the answer, I guess.
No, ma'am. Like
Ma'am, one more
I
thing.
could.
Can you elaborate more on what do you want to ask? Or maybe you can wait, and once we do that analysis in the breakout room, then
So, ma'am, that would be better probably.
Shruti is saying somewhat confused. Okay, ma'am, it is like better the commonality, more the item belong to construct. Yes, that is good because we want error to be less. If the error is high, that means the underlying construct is not affecting the item. So, Devakonda, you are very right. But again, I think Shruti is also confused. So I will explain this once because in the demonstration part. So just remember, I'll explain twice or thrice how it is being said or being interpreted.
Ma'am, one more thing, ma'am. This is only
Yes.
for the, not for causal factor analysis association, only for the first part. But construct
Can you be a little louder? I cannot. Let me increase the. Yes. Now, can you repeat?
yes, ma'am. This communality concept, is it applicable to the causal factor analysis also?
No, I said that this factor analysis is there for reflective, not for causal.
Only
For
for the
causal, yeah, for causal formative, we don't do factor this exploratory factor and confirmatory factor. There are other ways, that is the partial least square PLS method is there. PLS SEM, structural equation modeling parts. That's the another analysis actually, to be more precise. So this factor analysis is done for the reflective type of scale. That's very important because computer doesn't know now. Whenever you put item, it will give you the factor, but it's the investigator who should know. There will be many times there will be ambiguity. Then there are ways to check that also, like which is the reflective and which is the causal formative. Okay, but right now in this session we are focusing more on modifying the existing scale rather than making a new scale, because again I said that if you search the internet generally for construct measurement, the scales are existing. It may not be there in health, but maybe like I said, there you can go see the psychology and maybe the education sector. Those scales are there in some other business. So if social sciences, so scales are existing. So it's better that you modify rather than creating, because again, creating a new scale altogether, it's not an easy task. And we'll share a article on developing a scale of health literacy. And you can go through that article and you see that how much effort that author took in making that scale. Measurement of health literacy. Okay, so do read that article. He has created one scale. He's from Australia. I am forgetting his name. So we were going through that article. It is a very interesting read. So this factor analysis tells you about the item selection process, whether it was successful or not. So again, the same question, which I think one participant asked, like, what do we do factor analysis for these type of construct? Which type of construct? Reflective, formative, or both? Yes, you are right. So now coming to some cutoff, we will use these cutoff in the analysis. So the KMO value, what is a KMO? What does it measure? It measures the sample adequacy. So KMO, no Sony, we don't do this for both. We do it only for reflective. So it is more than 0.8. The total variance explained. That means the total variance of this construct explained by these factors should be more than 60%. Communality should be more than 0.4. And rotated factor loading, it should be more than 0.5. Or like you can take 0.4 also, but it should be more than 0.5. And Cronbach alpha, which we did yesterday, that we know it should be more than 0.7. So I'll tell you the concept of factor rotation, but let me first tell you regarding the factor analysis, few concepts which I have, otherwise you will be confused regarding its. This is the, maybe are my specs. So this is the data sheet you can see here. And I am, just for demo, I am again using that big personality 5 data. So you can see here, this was the options in analysis. And I'll go to this factor. Factor, you can see there is a principal component analysis, there is an exploratory factor analysis, and there is a confirmatory factor analysis. So first we are doing this exploratory factor analysis. So I've clicked that. So this option came here. In this case, you will see that these are the these are the items, and I have to shift those items here. So what I'll do, I'll take this E1 from E1, and I'll go till O10. And I have shifted it to this window. So now before the factor comes, it always gives you, but we have to check. I will uncheck all these because first you will check the assumptions. So this is the window for assumption check. This is the window for assumption check. In assumption check, you can see there is a Bartlett's test of sphericity and there is a KMO measure of sample adequacy. So you check both these because you have to check the assumption. So you have to come down. So the Bartlett's test of sphericity, what is the p-value here? So criteria 4. These are items. Where he is asking, can you explain criteria 4? Okay. Which criteria? Are you talking about this criteria? Okay, I'll tell everything. It is just for, we are going to revise. What is rotation? That's why I waited. Rotation, I did not want to introduce now. Let me clarify the other concepts which are there. Then I'll explain the rotation also. So this, what is the p-value? P-value is less than 0.01. So 0.01, then can I perform EFA on this test, this data set? This E1, E2, E3, it is the same questions which you people have responded. I mean, this is not the data which we have taken from you people. This is the data, some other data set. But these E1, E stands for, let me show you the data first. Because I always forget to show the data. So this is E1 and this is the 1 to 5 scale which you people have filled. So E1 is for, if you remember that the types of personality. So E1 was for the extraversion. So E is for the extraversion. And then if you come to, it was E1 till E10. Then if you see N, then N was for neuroticism. And then if you see A was for agreeableness. So all is having 10 questions. And then you will see that C was for the conscientiousness. And if you see the rest, these are again 10 questions. And this O is for openness, and N, that's it. So although we have divided, but we know, we assume that it is a unidimensional, and we don't know about the dimensionality of this data set. So yes, I have checked for this assumption, and this data I can perform the exploratory factor analysis. So again, I'll go here and I'll check with this KMO, measure of sampling adequacy. So you wait and it will come. So this KMO measure, if you see, MSA, the full form of MSA is measure of sampling adequacy. And you can see it gives you the overall sample adequacy as well as the sample of for each of these following items. So you can see all the values, any value which is less than 0.8, please check. Ideally, we say that less than 0.6 at least should not be there. There are some values you can see which is in 0.7 and then 0.7 also. So lowest is 0.7. Any value which is less than 0.6 or 0.5, I'm just scrolling. Please check. All of you. What is the overall KMO? Please type in the chat box. What is the overall KMO? 0.89. Yes. Agree. That means you are with me and seeing on screen. Thank you. And this KMO, what does it say? KMO? Okay. Yes, Dr. Nitin has gone one step ahead, writing meritorious. Okay, good. So we have checked for these two assumptions. Now coming to these options, can you say there is a method of extraction here? There is a method of extraction. And there is a method of rotation, which one participant asked regarding that factor loading, rotated factor loading. So if you see the method of extraction, there are two methods of extraction. If you click down, there is a principal axis, there is a maximum likelihood, and there is a minimum residual. So we mostly use the principal axis, and we can use maximum likelihood also. So principal axis, we will select this when the sample size is less and it is not normally distributed. That assumption. This maximum likelihood we use when there is a adequate sample size and when the data is normally distributed. Now coming to this rotation. If you see this rotation, there are various options. Varimax, Quantimax, Promax, Oblimin, Simplimax. Okay. Now I will go to the theory of rotation, which I did not tell. Then again, I'll come with this factor loading. So this is a summary. We'll again come back to this. So now coming to what is a factor rotation, because in factor analysis, you need to understand this term rotation. So you will have to imagine this, and I'll try to make you people understand what is this rotation. So imagine that wherever you are sitting, maybe you are sitting in your office or at your home. So it's a three-dimensional. You are sitting in an office or you are sitting at home. You are in a three-dimensional structure, maybe a room or a cabin, where there is a ceiling and the multiple color bulbs are hanging from that ceiling. Okay. And you are standing at one place. So what will happen? What you do, you measure the distance of all the bulbs which are hanging from the ceiling and you sum all these values. Okay. So this is X1. What I did, you are sitting in an office. Imagine that there are many bulbs which are hanging from the ceiling. you measure the distance of those bulbs from you and sum all the distance. Okay, that is your x1 position. Again, you change the position. From P1, you have now gone to P2. So from wherever you are sitting, you go to some other place. And from there also, you measure the distance of all the bulb and sum it up. So it will be maybe x2. Again, you change your position and you go to the position P3 and then sum all the distance now, and that would be x3. So there are three distances in respect to the three positions. So can you appreciate that there will be a position in this three-dimensional room from where the sum of all distances will be the least? Oh, please type in the chat box, yes or no. So Preeti is asking, writing yes. Okay, yes. So there will be a position in room from where the sum of all the distance will be the least. Those of you who have ever done a linear regression, you know there is something known as the line of best fit, where you that line of best fit is plotted where the distance between the residual and that line of best fit is minimum. Can you recall that? We draw a line of fit, and what is the residual? Residual is the difference between your expected or predicted and actual. So that is the error basically. So this line which you draw, that line of best fit is the line from where the individual data point, and that data point is the residual, that distance is least. That means your model or the prediction is that good. Similarly, this exploratory factor analysis, this also, if you just take the analogy of that and keep this also. So the rotation, it prefers that rotation where the distance, individual distance from the item to the person. So now what are the hanging bulbs in this case? Okay, that I'll come to that later. So what will happen if I ask you that the direction of movement is fixed? If I say, no, you can move only along wall, that means on perpendicular direction. You can go like this corner and then again take a turn in the corner. You cannot go oblique, okay? Or you cannot go zigzag. So, and in the other case, I give you the other option, like you can go oblique also. So what will happen if we restrict the movement of in your room space and we allow movement only in perpendicular direction? So will this restriction increase the chance of getting this point or restrict the chance? Restrict the chance? Agree? Okay. So now this 90-degree restriction, that is a type of orthogonal rotation. Okay. And this oblique is known as the oblimin. So now finally you got that point, and from this point you try to look at each ball and try to make some pattern in distribution of these bulbs. Like maybe all similar looking or shades together, all bluish shade bulbs or purple shade bulbs and all reddish shade bulbs. Okay. But many times you may not find any pattern at all. Whatever position you have, you will try to change your position, but you will not be finding any pattern. So now let's understand this rotation of factors to measure the construct of interest. So you have to replace this room space with your psychological space. So basically, yes, I'm coming to that, Shruti, to reach the minimum distance after restriction and find out the pattern. Yes, that rotation, I'll tell you this also, how to select. So first, with this room space, you replace this room space wherever you are sitting with the psychological space of that person. Okay, because construct is that psychological space of the study population. They replace the individual, the person which was moving, with the construct. So construct is moving, and replace the bulbs with the item which you have taken to measure the construct. So now that pattern which was formulated here in this slide, this is known as the factor. And the coming of this bulb into this factor is known as the factor loading. Remember, I talked about a concept known as the factor loading. So factor loading is something like the standardized regression coefficient. If you have an analogy of factor loading and regression, then it is similar to the standardized regression coefficient. So this person is a construct. These together looking, this thing is a factor, and this individual bulb is an item, and this whole room is the psychological space of the person. So if you have understood this, then I'll move forward. Okay, so Shruti have understood till this point. What about other people? Shruti, yes, I will come to that factor loading also, but just to make you understand the concept of the psychological space and the distance. So in psychological space, okay, Alpna is writing still not clear. Okay, Alpna. So can you unmute and specify? First, tell me what have you understood. Then I'll come to know what you have not understood.
Ma'am, actually, I understood that we are trying to get the place in this room and with this bulbs, which is having the least distance from you. You can change your place. And with restriction, when we apply restriction, we have diagonal or vertical rotations.
Okay, orthogonal or oblique?
Your oblique rotations.
Okay, so till this concept you have understood?
Yes, but ma'am, my doubt is there any chance that by changing the location, the grouping will be easier? Is it like that?
Yes. So just hold for a few minutes. Again, when I'll go back to JAMOVI, and when I'll change the method, then you will see. This is only theoretical thing. Practically, we'll see. So if you have understood up till now, I'll move ahead, and then you can understand. If you have understood this, you will understand that. I'm 100% sure. So just wait for. I know I have understood your doubt, and that will be clarified. Any other person who has not understood this concept, then I'll explain. Otherwise, the half part is still left. Nobody's writing anything. I don't know. Except Shruti and Alpna. What about other people? You can write not clear or clear. There are only two options. It's not a Likert. Like I only have given you two options. Prashant is writing clear. Nitin is writing clear, understood, clear. Okay, Alpna, it is clear to you. Okay, thank you. It will be more clear. Alpna, it will be clear to you. Only 5 to 10 minutes. Wait for 5 minutes. Okay. So in the psychological space, this distance between we actually calculate the correlation between, maybe we can have a brief overview of everything till now in 5 minutes. Okay, Shruti, I'll do that. Before we go to the breakout room, while explaining you the interpretation of the table, I will again come back to those theoretical concepts. So in psychological space distance between these construct item, factor item, and factor is measured as correlation coefficient. So you know what is a construct and you know what is an item. Okay. Construct is a latent factor. And this factor is what? It is the subdomain, the dimensions. And then there are item. So all these, you will see that we measure a correlation coefficient. So now see this picture. Maybe that bulb thing, which we tried to make you clear, and this will be more clear. So these are the maybe pipes which are kept in a room. So can you see clearly anything in this picture? This is without rotation. But if there is a rotation, these pillars are, you can see now it is ordered. Just by rotating that, it is ordered. And this was without rotation. So one was lying behind the other. But when you just turned it, now that order is clear. Means you are now standing at some other position. So can you appreciate the difference between these two diagrams? This I have taken from that Robert. I've told now that we have shared 2 books with you. There is a football analogy also in that book, which you can go and read. But I think we have tried to make you people understand. You can imagine that if you change your position in 3D space, the looking at individual item or the order of arrangement, it becomes clear. So now coming to this, this was the variable which we took. And then I'll again go back to my data. So this was the exploratory factor. Yes. Now coming to this, I have checked the assumption. So you can see here extraction. Now it is, you can see the rotation. So rotation, we talked about 2 methods. 90 degree, which is the orthogonal. So orthogonal is a varimax. Orthogonal has 3 types: varimax, quatermax, and simplimax. And this rotation oblique has got promax and oblimin. Okay. So generally we apply oblimin. Why? Because the author says, although people like maybe the Robert and also that JAMOVI statistical book, that says that in social science, generally it is the oblique, and there is one more criteria. When there is a good correlation between the factors, then you should go for the oblimin. So I will see the correlation also, but start with oblimin. Oblimin means I have taken this as a method of rotation. And here also you may do it as a principal axis. Why principal axis? Because if the data number is less. But again, you can see that if there is a sample adequacy, you can go for the maximum likelihood also. Then you can see something known as the factor loading. Now, what is this factor loading? Let me first tell you. So I will explain this. You can see that these are the items E1 to O10. These are the 51 items. And then you can see the number of factors. So it has broken these into 7 factors. 1, 2, 3, 4, 5, 6, 7. Now you see that these E1 to E10, this is getting loaded on factor 1. This N1 to N10 is getting loaded into factor 2. These A1 to A10 is getting loaded on factor 3. And this C1 to C10 on 4 and then O on 5. Then very less factor are getting loaded on 6 and 7. Why there are blank spaces here? Anyone? Why these spaces are blank? Error. So no, just see this because of this option. What is the option here? What is the default hide pattern? Pavni is writing the items are in another factor group, it's hidden. Yes, why it's hidden? Because the default command is hide the loadings below 0.3. And this loading is what? This loading, you can say that it is basically, remember that this point which Preeti, I don't know who asked this. I'll just go and show this. You asked about this, no? Criteria 4. To explain the criteria 4 once again. So if you see this criteria, rotated factor loading, ideally it should be more than 0.45. Okay. So if this is basically the rotated factor loading. I have kept it as 0.3. If you keep it 0, then see what will happen. Then can you see now all the columns are populated? Now there are no empty space. Pavni and other participant, Rupali, I can see your name here. Can you appreciate this? So if you keep it as 0, that means it will not hide anything. So, but I want, why? Because I want at least there should be the factor which are less than 0.3. Ideally, it should be 0.45. This is the rotated factor loading. This is the same criteria which I was talking here, that the rotated factor loading should be more than 0.5 to say that it is getting loaded on a factor. Now again, I'll make it to 0.3. And then you will see that after changing this, just click on the output window. So you can see now again this has, so it says about the factor loading. And you will see that all the factor value of the factor loading is more than 0.3 here. Now coming to the other number of factors. So remember, we talked about the number of factors. There are ways to create the number of factors. The cutoff can be decided by the investigator. Yes, the guideline is that it should be more than 0.45. You can't take it like 0.2 or 0.1, but there is a range. You can take 0.3 to 0.45. It is up to you, Preeti. But yes, investigator also decides the cutoff based on some recommendations. So now you can see here, number of factors. So how many factors I should keep? It has given me 7 factors. But I said that if you see this option, number of factors. So there are 3 ways to calculate the number of factors based on parallel analysis, based on eigenvalue, and fixed number. So I have clicked parallel analysis. This is considered a best. Okay, so Rupali is asking what is extraction. So extraction is like, it is taking the number of factor. Extraction is similar to that clubbing the similar item together. That is similar to extraction. Remember the first or second slide where I have shown you that there is a net and the bulbs are going through that net, balls, and getting clubbed into a similar shade. So that similar shade, clubbing into the similar shade is the extraction. Though that is the factor extraction. And rotation is one method by which these distance will be less and the visualization will be more clear in psychological space. That is rotation. So these are the 2 methods, extraction and rotation. Is it clear, Rupali? Yes, I'm coming to that, Koteshwarama. Wait for 2 minutes. So I said that how to decide for the number of factors. So are you clear up till this point? I'm going a little slow because then we won't be able to complete. Yes, there are 3 options in extractions. I think I have told this. Yes, can someone repeat what I told in maximum likelihood and principal axis?
Maximum likelihood is used when the data is normal and adequate sample size.
Agree.
And principal axis is used when the data is less or maybe non-normal.
Okay, yes, perfect. So did you understand, Rupali? This minimum residual, I did not get this thing, but till now I am clear on these two options. And mostly we use these two, principal axis and maximum likelihood. Rupali, are you clear on this? I think she's not responding. Let's go ahead. What about the other concept? Till now, are you clear? So yes, she's asking me regarding the how to take the factors. So come down now. This we have checked. This is KMO. You have seen. And based on parallel analysis, number of factors. But why I'm not just based on eigenvalue? If you come to this plot, you can see there is a scree plot here. And then there is a, I'm not going into right now these model fit, but these factor correlations are important. That's why I've clicked it. Now coming to this eigenvalue. Yes, first let me explain this. So based on eigenvalue, you can see it has given you 5 factors. And if you see the scree plot, this is the scree plot. Can you see? So if you take the inflection, actually this is like from here the deflection is happening. So it is up to you. It is given you 3 and 2, 5 factors. Before that, after that, it has gone down. And if you take this 1, because it says that the eigenvalue should be more than 1. So either you can use the scree plot or you can go and see the individual eigenvalue. So like Dr. Nitin was also asking about the eigenvalue at every level. So eigenvalue, maybe I can factor summary. And then you can click this. So these are the eigenvalue. You can see the individual eigenvalue of individual factors. So if you focus here also, you will see that we have to take the factors where the eigenvalue is more than 1. So it gives you 5 factors. Because the 6th one is having an eigenvalue of 0.91. So we'll take these factors. So if you use this Oblimin rotation and principal axis method of extraction. So yes, I'm repeating it. I'll repeat it many times. Don't worry. So what I did, I have there. This is the option of number of factors. So there are 3 ways to decide for the number of factors. You can go for the scree plot. You can take the eigenvalue and you can do on the basis of parallel analysis. So I said that parallel analysis is best. So if you click on parallel analysis, your scree plot will be the same, but there will be another graph which with the random population. So this is the yellow balls are for the simulation, and this is from the data. And you can see that it is also giving you 1, 2, 3. It is giving you 6 factor. And this is giving you 5 factors. So now it depends like how many factors do you want to take. If you come up, you can see it, if you take this parallel analysis, it is giving you 7 factors here. But again, if you take the eigenvalue, then it gives you the 5 factors. So if you change these options, the number of factor will change here. And then this option, I have told you that these are the blank spaces because I have hide the loading below 0.3. Coming to the another table. This is a table. Factor statistics. So it has extracted 5 factors, and this is the loading, sum of square loading. SS loading is sum of square loading, and this is the percentage of variance. So if you see this, this is the percentage of variance. Means factor 1 is able to explain 10% of variance in the that construct is explaining 10% of variance in factor 1, the 9.47% of variation in factor 2, 7.97 variation in 3, 6.69 in 4, and 6.35 in 5th. So these 5 factors together, if you see the cumulative, it is able to explain only 40% of your variation. And if you go and see the criteria, what criteria we discussed? What should be the total, how much should be the total variance explained?
Above 60%.
Yes, rest of you, please see and tell me, type in the chat box. Pavni is writing. What about others? Dr. Madhav is writing. Anuja is writing. Okay, so now you know. Thank you. So now I'll again go back. And I'll go to that JAMOVI output. So it is able to tell you only 40%. I think I was there. 40% of variation. So this is not a good variation. It should have been more. I'll just, yes. Coming to again this inter-item correlation. Okay. Sorry, inter-factor correlation. Now I'll have to explain 2 concepts here, which is the construct validity. So before I go to construct validity, let me show you the uniqueness part, which Dr. Shruti was also asking to explain it. Now, can you see a column of uniqueness here? Now for this item, E1, the uniqueness is 50.51. What does it convey? Yes, all of you please write in the chat box. I have explained the uniqueness and communality to you people. So what will be the communality for this item, E1?
0.49.
Ma'am, 0.49.
Okay, agree. And how you have decided for that? 0.49? What is it?
Ma'am, 1 minus 0.51.
Yes, very good. 1 minus 0.51, good. So uniqueness, and so what is communality? You said, so Pavni is writing almost 50% of error contributing to construct. So in reflective, do we write like that, Pavni?
Ma'am, it can be either error or maybe this particular item may be reflective of some other construct.
Yes, agree. And Dr. Nitin is bilkul sahi that he has written 49% of variation in E1 is explained by construct. Perfect. That is the way you should be interpreting it, because it is a reflective scale. So you cannot write that item is causing that construct. The variation, because you are measuring the item. So the variance in the item is due to the construct. And the 51% is the uniqueness, because 51% is either, like you said, either due to some other construct or due to some other error. Okay. Or none. So, okay, ma'am. Okay, Pavni has got it. And then if you come down, you will see the, so Shruti, are you clear on this uniqueness and communality? Okay, thank you. So now coming to that criteria, if I see that, So you know now what is a KMO value. So KMO is the, for sample adequacy, it should be 0.8. Total variance, you now know it is 60%. Communality, it should be more than 0.4. That means uniqueness should be less than, it should not be more than 60. And then rotated factor loading is 0.45. This also you know. And Cronbach alpha also you know. Now I'll again come back. And this one. So coming to this, if you see the uniqueness, what is the uniqueness of this is 39. So in this case, we said that communality should be more than 0.4. So if the error in this case, what is the communality, or we can talk about the error also. Error should be less than 60. So what is the error in this case? Error or uniqueness? This variable. What about this item? What about this item? And this item. Sorry. So what is your comment on these four? Yes.
It's less than 0.4.
Less than what? Okay. So here you can see it is more than, error is more than 60%. Yes. So error is more than 60%. So what you should do with this? Then you can say that it is not, these items are not, the variance in these items is not because of this construct. So you may delete this item in your final scale, which you will create. Because for your population, the error term is very high. And this is not getting explained by the construct. So you may take a call to remove or delete this, and then again rerun the factor analysis. So have you understood this? Uniqueness and communality. All of you please say, otherwise I'll repeat once again. Okay. Then coming to the other output, I have explained this SS loading and variance to you, and this inter item I have not told you. This MSA I have told, and this eigenvalue also I have explained, and I have explained this scree plot to you. So now coming to this construct validity. Remember, we talked about the construct validity, criterion validity, and content validity yesterday. So content validity was what? You check whether the items, the content of the item is measuring that construct or not. And how do you check that? You send it to the expert, like we send it to you people, and then you have reverted back, and then we have calculated the content validity ratio and then content validity index. So content validity ratio is for the at the individual item, and content validity index is for the individual item as well as the overall scale. And the value should be more than 0.8 for content validity index. And for content validity ratio, which is the Lossy method, it depends on the rater. How many raters? And based on that, you decide for the cutoff for the content validity. So those were the two objective way for the content validity. Coming to the construct validity. Construct validity, there were two types: discriminant validity and the convergent validity. Now, what is that? So that we test here. So in this case, you can see the inter-factor correlation. Now focus on this table. Inter-factor correlation. So this, if the inter-factor correlation is less than 0.3, in this case, you will see that none of the factor This is the correlation between factor, like 1 and 2, 2 and 3, like that. So none of the values are greater than 0.3. So if interfactor correlation, if none of the values are greater than 3, then you can say that there is a discriminant validity. What do you mean by discriminant validity? Means each factor is having a separate domain. There is no correlation between the factor. That's why they're getting less correlation. I should not say no, less correlation. And that cutoff, we have kept it as 0.3. So this is the discriminant validity, means each of these domain or factor, they are different from each other. Like in this case, the consciousness is different from the openness. Openness is different from the agreeableness, although they all are a part of personality trait. Okay. But like we said, in case of affect, remember we said that affect has got two parts. So similarly, a bigger construct is broken into a smaller part. And that is condensing the data. Remember, one of the function of factor analysis was the condensation of the data. So that purpose it is doing it. So this is known as the discriminant validity. Now, what is a convergent validity? So how do you check for that? So you take any individual factor. So let's say you take this factor, factor 1, and you see how many factors are getting, how many items are getting loaded on this factor. So basically it is 1, 2, 3, 10 factors. This is getting loaded on, 10 items are getting loaded on factor 1. So you have to take a mean of all these 10 values, removing the minus sign. So all of you, please calculate the average of these 10 values. All of you, please. 0.71 plus 0.73. Please do it over your phone and type it in the chat box. Okay, I'll repeat it, Dr. Salman. I'll repeat. Yes, we have to neglect the negative sign. Yes, all of you, please calculate and type in the chat box. .659. Vishnu is writing 0.65. Shruti 0.65. Okay. 0.65. Okay, Sony. Yes. So if all of you says 0.65, that means it is 0.65. It should be at least 0.7. So this is also not met. So if the mean of all the correlation, if it is less than 0.7, then the convergent validity is not met. So that you will write that convergent validity is not met. For a convergent validity to meet, at least the mean of this should be more than. So like there are some items where if you see this one, 70% E8. Can you see this E8? This is 70. So if I remove this E8, what will happen? And this E8 is having very less correlation. So you will see, and this E6, yes, E6 also. So if you remove this E8, and maybe E6, so if you remove this now, this is getting loaded on this factor 2. So now calculate the mean, all of you. Calculate the mean of this factor 2. All of you, please redo it again, because I have removed 2 items, which was having more error or more uniqueness. So I have removed it. Okay, so it does not, it is only 0.68. Okay, so again, that means the convergent validity, in spite of removing the 2 items, the convergent validity is not met. Again, if I see this item E9, this is also showing 61%. If I go down, let me check. So 2, this is also getting loaded. But again, this is getting loaded and its error is also high. So maybe this E10, this is again so its uniqueness is 61. So no, this one. This is okay. So you can just see like the less, more uniqueness, it will contribute to less of correlation and more of error. So this is how, in spite of removing the item, this convergent validity, it is 0.68. Yes. Now you can calculate it with some other thing. Can you calculate it with this? Here also you will find that it is very less correlation. It will also be less. But can you do it for this factor, factor 1? It will also. So convergent validity is not that good. It is less. And the discriminant validity is good. So this is the finding of your factor analysis. Now, there is something known as the simple structure. Now, what is that simple structure? So you do this in your data set, then you will find out. This is again a data set which we have taken from the JAMOVI. In the breakout room, you perform this analysis and then see how these factors are getting loaded on your stars, that is the statistical anxiety score. So now, coming to this simple structure. Now, there was one more criteria. There should be a strong loading of the factor. So E1 is getting loaded on 1 factor 2, and this has got a very strong loading. How do we call as a strong loading? At least value of this loading should be more than 0.5. So this is 0.74. All the values are strongly loaded. And in this case also, the values are more. This also, you can see. But what about this A10? So can you see this A10? The value of A10, this is getting loaded on 2 factor. It is known as the cross loading. Yes, Vaidehi, I'm coming to, I'll explain everything once again. If a factor is getting, if an item is getting loaded on more than 1 factor, it is known as the cross loading. So A10 item is getting loaded on 2 factor. So this and that too loading is very less. So you will remove this A10 also. So what I'll do? I'll remove this A10. Now you see this factor C3. It is again getting loaded on 2 factor, but 1 is okay, it is 0.49. But what about this C4? This is again a cross loading. And here there is no cross loading. Okay. So this was the analysis of, or the interpretation of this table. So I'm repeating everything once again. So up till now, what we did? We have opened JAMOVI. We have, through this option, we have, yes?
No. Can I put in one suggestion?
Pardon?
Am I audible, Dr. Can I put in some suggestion?
Yes, please.
Dr. Pragya, can you see, these are all the different aspects which we need to see in EFA. Can you, since you are summarizing now, can you just go stepwise? Like, suppose if we get a questionnaire and we decide to do the analysis, so what should we look first? Should we look at the Bartlett's test of sphericity first and then remove something? Then we should go to the next and then remove something, so that it becomes a little structured at how we should proceed.
Okay, I'll once again, let me explain that discriminant and convergent validity, and then I'll come that stepwise. So discriminant validity is when you see the inter-factor correlation. So this inter-factor correlation, if you see, the value is less than 0.3 in all the inter-factor correlation. That means there is a discriminant validity. Means each factor is less correlated, and less correlated, how we have defined, it should be less than 0.3. Coming to the convergent validity, for convergent validity, you take a mean of all the factor loading here. And if the factor loading is more than 0.7, the mean of the factor loading is more than 0.7, then you say that it is, battery is sick. Then it says that it is meeting the convergent validity. If mean of this more than 0.7, then it says that it is meeting the convergent validity. So all of you calculated the mean and it said that it was 0.65. Then I removed some item. And what item I removed? I removed the item which was having uniqueness more than 60%, more than equal to, because that was showing that error is more. So that was regarding discriminant. Now coming to again stepwise. So this exploratory factor analysis, I'll move everything back. I'll show it once again, how we have to go stepwise. So E1, I'll press shift. I will uncheck everything. Here also. Okay. So this will be the initial look when you will open the exploratory factor window in JAMOVI. So what I have to do, I have to shift all these variables. So I'll select all these variables and shift these variables to this window. Now, before I do anything, I have to do the assumption check. So for assumption check, I'll click. Even if you don't do this, this is the automatic this thing. It will really give you the factor. But before I go to this table, I'll check for these two assumptions. So if your sample size is adequate, generally these two assumptions are met. Then you'll come down and you will focus on the Bartlett's test of sphericity and the KMO measure. So Bartlett's test of sphericity is, you can see that it is the less than 0.001, it should be less than 0.05. That means it says that this is, you can do the test, because it says that the factors are correlated and the items are correlated with each other. That suggests this. Now coming to the KMO measure of sample adequacy, this should be more than 0.8. So overall is also more than 0.8, and this individual is also more than 0.8 ideally, and you know that there is a classification, but it should not be less than 0.6, that meritorious and marvelous. So you have checked all these items, and then you will come to assumption is satisfied. So this was step 2. Now
So
coming
Dr.
to this,
Dr. Pragya, if anything at this place comes to be more than 0.6, then should we remove that item?
less than 0.6.
Oh, sorry, less than 0.6. Then should we remove the item here only?
No. It's better that don't remove it. It's better that you take some more samples. Like you can go and,
Okay.
but again, that initial, so obviously that sampling thing you cannot do immediately. It will take some time. So you can keep your analysis till the time
Right.
you can like try removing that item, and analyzing it. But removing the item from scale altogether, it's better that you take more samples, because expert have devised these items and you have done pre-testing also. So you have through to all those steps. So you cannot say outrightly that, this is not a useful item. But again, in your population, if you take some more sample, then you can say that in your population, this doesn't seem to be a important item. Okay.
Okay,
And
Dr.
then-
Pragya, the thing is that we can take more samples, that is correct. But at some point of time, we have to put a finish line to the study.
Yes.
Because we cannot just keep on taking samples, because they. So
If
suppose
we
if we
like
have done everything, we have taken more
already,
samples, but still it is
yes,
coming.
then you can remove it. You can remove it. Not
Okay.
now, maybe after that factor thing.
Fine, thank you.
Not now, not only on
Factor thing, correct.
removal of the item is not only on the basis of KMO measure. Like you see the factor loading,
Okay.
you see the cross loading, you see the variance, uniqueness, communality. So all those things together makes a decision taking process whether to keep that or whether to remove that. It's not only on the basis of KMO.
And one thing, Dr. Prakash, if suppose at the very outset, the Bartlett's test of specificity is not coming significant, it is coming more than, suppose it is coming 0.46, then what is the interpretation?
0 point.
It's coming
So then, if overall it is coming 0.46, that means it is not significant, or then you cannot perform EFA. Because
then we cannot perform EFA, exactly.
Yeah, that is clear. You cannot perform. The data is not suitable for EFA.
Suitable for
Okay.
EFA.
Okay. Now, this was step 1, and then step 2, you will come to this methods. Automatically it takes, like it has taken because I have given this option, but you will decide about the rotation and you will decide about the method of extraction. So method of extraction we discussed, there are 2 methods, principal access and maximum likelihood, which are commonly used. If data is adequate, you can go with the maximum likelihood. If you could not collect that much data, then you can go with the principal access. Rotation, we know about, there are 2 types of rotation, orthogonal and the oblique. So these Varimax, Quantimax and Simplimax are all the 3 are type of orthogonal. Now I'm not going into the detail of when to use Quantimax and when to use Simplimax. Okay, don't go into those minor statistical jargon. You can, most of the time you will use these Varimax or you will use Oblimin. So I'm using Oblimin because the social scientist, the 2 authors, they suggested that if the correlation is more than 0.3, then you should go with the Oblimin if there is a good correlation. So in my case, all the correlation you take a decision of like going with this Oblimin, and then in the 3rd step, it comes the number of factors, how the number of factors, on what basis you want the number of factors to be extracted. So either you want to take a parallel analysis or on the basis of eigenvalue or what. So maybe if I have taken the eigenvalue, then you have to go and see. For that, you have to click this initial eigenvalue, this an additional output. You will see there is something known as the initial eigenvalue. So it will give you the eigenvalue of the individual factor also. You can see here, and you can say that till factor 5, it is more than 1, and after that it is less than 1. So it 5 factor. Then coming to the factor loading. So factor loading, you have decided that you will have a table with the factor loading more than 0.3. And then coming to the additional output, you see the factor summary, factor correlation, scree plot. Model fit, I'm not clicking because generally we see this in the confirmatory factor analysis. So this I have done, and you can see interfactor correlation. This is the basis of convergent validity, and discriminant validity, and the convergent validity more than 0.7 up, which we have discussed. Right, this problem with the charging word.
Yeah.
So I think we can we go to the breakout room now, because and it is requested from the mentor